Hello, everybody. This is Nick Totaro, Professor of Information Technology and Computer Science, Lakeland Community College. Let's talk address resolution protocol. When we're dealing on networks, whether they be wireless, whether they be wired, whatever, the devices have to be able to obviously communicate with each other, and how they do that. How do they establish specific addresses? How does one computer know to talk to another computer? What is going on there? We as human beings, we like to give computers names. The World Wide Web server at lakelandcc.edu, the mail server at such and such a place. But computers don't think in those terms. Computers have to think in those little bits and bytes and ones and zeros and things like that. And when you're dealing with electronic devices, they actually have to talk to each other. It sounds silly, electronically, with pulses and signals and things like that. So I want to go up and we're going to talk about ARP, Address Resolution Protocol. I have a little network, I have a little test environment that I'm going to do some demonstrations on. And this is going to be the beginning of this whole concept of resolving from those electrical circuits up to names that we would understand. But we're just going to deal with how do the computers send those electrical signals. So let me go up to my screen. All right, here's my little network. Real quickly, this is a little test environment that I use. Up here is I have a firewall. The network is on 10.0.1, whatever that may be. And up here we have my firewall, and the IP address for the firewall is 10.0.1.1. Then I have a series of computers down here. We're only going to be worried about the 4 computers you see that have the IP addresses, the firewall, and then I have a computer called Godzilla. That is a Kali machine that I could do a whole bunch of networking functions. And then I'll have like 2 client machines. I have a client machine called Alice and a client machine called Bob. Now, if those machines wish to talk to each other, they have to communicate through some kind of electrical pulse. So they have to identify themselves electronically down to that physical layer of our OSI reference model. And you will notice at the very lower layers here, I have these very cryptic numbers, 08002734FF9F, and Alice is 08002747C1A7B. That is what is referred to as the MAC address, or the machine access code address. Those are unique addresses that are burned into the network card that the devices actually use to communicate with each other. The problem is, we as human beings, we don't like those numbers. They're just too hard for us to memorize. Now, there is a pattern to that. Not going to worry about the pattern, but basically the first 3 sections, the 080027, that's the manufacturer number, and then they have the unique address for that individual card. No 2 machines can have the same machine access code or MAC address on the same physical segment. There's some things we can do, and that's more for an ethical hacking course. But for right now, let's go into the premise that none of these machines will have the same MAC address. But those numbers, again, are just too hard for us to remember. So what we do is we put a layer above that. We put those IP addresses. So take, for example, Godzilla right here. Godzilla has an IP address of 10.0.1.2. Alice has an IP address of 10.0.1.3. Bob is 10.0.1.4. And my router is 10.0.1.1. Even those numbers are difficult for us to remember. Can you try to think in a situation where you're surfing the internet and you have to sit there and memorize IP addresses? That would be ludicrous. So we will put a naming convention even above those. So I like to refer to things as Godzilla or Alice or the www server at lakelandcc.edu. Not going to worry about that. That has to deal, the resolution, the name resolution between the IP address and the actual name of the computer is we use DNS. That's not what this video is about. So just remember that, keep that in mind. The resolution between the IP address, something that human beings assign, and the computer name, that is done through DNS or potentially host files. In this video, I want to examine this down here, the resolution between the MAC address and the IP address, what is referred to as the Address Resolution Protocol, ARP. You hear that all the time. ARP is the resolution between the MAC address and the IP addresses that the computers use. So if Alice wants to talk to Bob, and let's say Alice has never talked to Bob before, she has to find out Bob's MAC address. So she potentially have the IP address, and Alice will initiate a conversation based upon the IP address. But before that conversation can occur, there has to be a resolution. So Alice needs to find out, and that's what resolution means. Alice needs to find out the MAC address. Alice may have the computer's name, Alice may have the IP address, but initially she may not have the MAC address. So this is done through something called broadcasting. ARP, Address Resolution Protocol, is a broadcast protocol, meaning that when Alice wants to talk to Bob, one of the first things she will do is she will say, "Who's Bob?" And everybody has to hear that. In broadcasting, everybody has to hear that initial, "Who's Bob?" But only Bob needs to respond. So Bob say, "I'm Bob, here's my MAC address." Now, in networking, broadcasting is, I said this for years, a necessary evil. We don't like broadcasting on the network because when we broadcast on the network, everybody has to pay attention to it, which could take time and resources. So one of the things we want to do is, or the networking they do is, they reduce the amount of necessary broadcasting. It's necessary. ARP relies upon this broadcast. It's like walking into a room and say, "Who's Bob?" Once I find out who Bob is, then I can establish communication. Now, to reduce broadcasting, I don't have to do that all the time. If I've established a communication with Bob before, I know who Bob is. And in networking, that's done through ARP cache. And this will make more sense as I go through the demonstration. So keep a couple things in mind. Computers need to use the MAC address to make a connection. Computers need to do a resolution between the IP address and the MAC address. The IP address is assigned by a person. The MAC address is assigned by manufacturers. I'm not going to worry about that. But the IP address is assigned by a person. The MAC address is burned into the card. The first time that there is a need for a resolution, that machine has to rely upon broadcasting. Broadcasting is that necessary evil where it says, "Who is Bob?" All the computers on that network or on that segment by the switch has to listen, but they'll ignore them. We don't like broadcasting. It generates additional traffic, and everybody has to stop what they're doing and responds. So after the computers do that initial broadcast, do the resolution, then that computer will put the other computer's MAC address and IP address in what we call the ARP cache. It'll make more sense in a second. Okay, I'm up at my computer. If you remember, there are really 4 computers that I'm dealing with here. I'm dealing with the router, I'm dealing with Godzilla, I'm dealing with Alice, and I'm dealing with Bob. At this screen, I am dealing with Godzilla. I'm going to be using Godzilla. And you can look, it looks like a blank screen, but actually there's a program running. Down here on the lower section of this screen is a network monitor called Wireshark. And what this is going to do is it's going to keep track of any traffic that it hears, right? And because it's on a switch, it will only hear traffic that is directly related to itself. It will not hear other traffic from other computers. So we're going to start simple and just say, okay, right now I am just monitoring traffic that is directed to Godzilla. It's not going to care about the other traffic out there. So up here is Godzilla. This is just a command prompt. And I want to see if Godzilla has done any address resolution. So I'm going to do a command called ARP-V, just means show me the ARP table verbosely. And right now, this tells me Godzilla has done no resolution. Godzilla doesn't know any computer on the network right now. Okay, fine. So we're going to keep things simple. And what I'm going to do is start simple. I'm going to surf the internet from Godzilla. Now, the moment I clicked on the browser, almost immediately, if we go down here, and this is just a web browser, almost immediately, Godzilla had to do resolution. It had to do a couple resolutions. One of the resolutions it had to do was find out, how do I go out there and how do I find the any content there. This was just a basic home page. So you can see immediately down here, it might be a little hard to read on the screen, Godzilla did an ARP. Godzilla basically said, I need to talk to my router because I don't know how to get to a particular web page. So I need to talk to my router. So inside the configuration of Godzilla, I told Godzilla, your router is 10.01.1. All right. So one of the first things that Godzilla did was it did an ARP request, meaning that said, hey, who is 10.0.1.1? And everybody had to listen, but only the router, only 10.0.0.1 responded. And that's what's going on here. So that's the ARP traffic. If I go back up to my screen, clear it, and I say ARP-V, you can now see that I have an entry in the ARP cache. Now, the cache will go away when I reboot the machine, but you can see I have an entry. And inside the ARP cache is the name of the router. It doesn't show the IP address because it has a host name for it, right? And it shows the MAC address for that router. So this particular router has a MAC address of 0800270598EF. Keep that in mind. Every time a computer needs to do a resolution, the first time it does that resolution, it broadcasts as who is X, X responds, it puts in. Now, if I do any kind of traffic to the router, we won't get ARP requests because the ARP is in the cache. So if I go back to here and I just, okay. My machine is very slow, I apologize. So it's going out there and it's finding the Lakeland address. Give it a second. Okay. So it went out there and found the Lakeland address. You'll notice down here, let me close this. I'll close my browser. I'm pausing the video so you don't have to see the 2-3 minutes delay there. And you can see I didn't get any more ARP requests on that going to the browser because, again, broadcasting is a necessary evil. Because we established who the router was to get me to Lakeland, that's now inside the ARP cache. So let me, and right now all I'm doing is I'm filtering the ARP. I'm pausing because the screen can take some time. So let me go back up to here and let me clear the screen again and let me do another ARP-V to see what's inside my ARP cache. And this time what I'm going to do is I'm going to reach out to Alice. Alice's address is, let me just double check this. Alice's address is 10.0.1.3. So to reach out to it, I'm just going to do a simple ping. Let it run for a little bit, and I'll stop the ping. And if I go down here, I'll make it, you can see that, where is it? Right here. This address, this initial ARP here. This is that broadcast. This is the ARP broadcast says who has the address 0.0.1.2 tell 0.0.1.3. Actually, it's where is it? It's here. Who has, that's the actual, who has the address 10.0.0.1, please tell 10.0.1.2. And then there were some negotiations, and those are all the broadcasts. Now, if I was to do a ping again, the ARP's not going to happen. But if I go up to the screen and I do an ARP-V, you can now see right here that is the address that has been resolved. So this is now in my ARP cache. It says anytime you want to talk to 10.0.1.3, you don't have to ARP anymore. You don't have to do that broadcast. Here is the MAC address. You notice that the MAC addresses are different. Even if I was to ping 3 again, it's not generating ARP traffic, okay? Because it's already done that resolution. Let's do one more resolution. Let's double check, right? There's only 2 resolutions there. One is the PFS set is my router. The 10.0.1 is the Alice. Let's do Bob. So if I say ping 10.0.1.4, that's Bob. I hit enter. You should have seen there was a jump down here for Bob. Let's see, right there. It says, who has 10.0.1, please respond back to 10.0.0.12, back to my machine. So now my ARP cache, clear the screen, has 3 resolutions on it. If I was to look at the other computers, if I was to run Wireshark at the other computers, they would see that initial ARP, and then they would ignore it, right? They say, okay, it's not me, or they would respond to it if it was them, but if it wasn't, they would just ignore it. What I'm going to do now is I'm going to start over, but this time I'm going to pause my machine so I can get my computers up and running. I'm going to pause my machine, and I'm going to start fresh on the Wireshark, right? So there's nothing there. I don't want to filter anymore. It's only filtering ARP. Let me stop and start this. Hold on one second. Because my computer's so slow, when it takes time to reboot, I'm going to pause here. What I'm going to do is I am going to go to Alice, and I'm going to just ping Bob from Alice. And I want to see what traffic Godzilla is. So let me bring up my screen for a second. All right, so what I'm going to do is I'm going to go to Alice, and I'm going to ping Bob. Because we're on a switched network, I should not see any traffic at Godzilla. So I'm going to Alice, pinging Bob, but then I want to see what traffic Godzilla is listening to. Now I should hear the ARP because Alice has never pinged Bob before, never made contact with Bob before. So we should see that initial ARP on Godzilla, but nothing else. But the traffic will still be going through with between Alice and Bob. So give me a second. All right, so again, I'm pausing because it just takes too long to fire some things up. I'm going to go to Alice, And she's up here in the screen. Alice is being represented by Alice in Wonderland, so I know what computer I'm on. Godzilla as its wallpaper. And down here is the network traffic. Let me be clear on this. Down here is the network traffic for Godzilla. Godzilla is on, all these computers are on a switch network, so Godzilla should only hear traffic to itself. It should not hear any traffic between Alice and Bob. So let me go to a command prompt on Alice. And you know what? I'm going to stretch Alice out a little bit. And I'm at a command prompt. If I do the exact same thing at Alice and I say, what does your ARP cache look like? Right now, she has not done any resolutions. So she is now going to ping Bob. Bob's IP address is 10.0.1. Let's see what happens. And there. Now, right now, Alice is talking to Bob. She's pinging Bob and Bob's responding. But you'll go down, now we go back down to Godzilla. You will notice Godzilla only heard that initial ARP because broadcasting everybody has to listen to. Once there's a communication established, then the switch is going to take over and say, Godzilla doesn't have to see that traffic, but Godzilla, or actually all the computers, had to see the ARP. Okay, so in this video, we just started with basic resolution. The resolution, or ARP resolution, address resolution protocol, is used for the resolution between the MAC address, the machine access code address, or the machine address, the electronic address, to the IP address. Right? We haven't even looked at DNS or host names or anything like that, so keep that in mind. When a computer has to establish that first communication, it has to establish from the MAC address to the IP address. Now, the question you may be asking is, if I'm surfing the internet, do I need to know the MAC address of the internet server? No. You saw earlier in the video, when I surfed to Lakeland, I just had to have, that client had to have the MAC address to the router to get it to Lakeland. So that's how MAC addresses are only shared on a given computer segment, network segment. So when I went to Lakeland, I did not need to know the MAC address of Lakeland. I just need to know the MAC address of my router. Now that router needs to know the MAC address of the next router down the line, et cetera, et cetera. At a certain point, when we get to the Lakeland router has to know the MAC address to the web server. So all this is done through those MAC addresses. So that being said, let's go and learn something.